For my project, I have implemented the paper Laser Speckle Photography for Surface Tampering Detection. In many scenarios, such as forensics or crime scene analysis, it is often desirable to know if and where a surface has been touched or tampered with. Given a pair of regular images, it is nearly impossible to find where a surface was tampered with. What we want to do is, given a pair of before and after images, we want to be able to determine the region that has been tampered with and be able to generalize a technique that can work with a large number of surface types. Unlike with traditional forensic analysis techniques, we do not want to change the surface at all by applying fingerprint powders. The paper Laser Speckle Photography for Surface Tampering Detection uses the idea of laser speckle imaging to solve this problem. The idea is that the laser speckle reflections in an image of a surface illuminated by a laser are different when the surface deforms. In the figure on the left, the speckle image before touching the surface is different from the one after touching the surface. This is due to a variety of factors, which may include oils from your hand being left on the surface, causing the laser to have a different specular reflection, or the deformation of a surface after applying weight, which will also cause the laser to have a different specular reflection. For my project, I recreated the experimental setup of the original paper. I have a DSLR camera pointing to a surface illuminated by a micro laser projector. I took a before image before tampering with the surface, an image showing how I tampered the surface, which is only used for reference, and an after image, after I finished tampering with the surface. Given the before and after images, I first convert them to luminance images using the XYZ color space. The paper shows that speckle images are affected by camera translation. In this figure, notice how the captured image is different as the camera translates. So, I need to ensure that the two images I take are not offset by a translation. To do so, I tried my best not to move the camera between shots. For accurate recovery, we need to align both images to the same viewpoint, in case the camera has moved between taking the before and after images. To ensure this, I randomly sample 100 speckle image patches in the before image and find their corresponding matches in the after image. Using these correspondences, I compute a homography between the two images and apply the homography to warp the after image to the same viewpoint as the before image. Then, I use the normalized cross-correlation to compute a similarity map. You can see here that the map is properly able to image my hand on the wall. I ran a number of experiments to test the robustness of my implementation. In my first experiment, I show that the system can detect a hand placed on a wall. I also tried on a specular whiteboard. The system is able to show a faint detection of my hand. Placing a quarter on a cardboard box causes slight deformations due to the weight. The system is able to detect a quarter in the similarity map. My system can also detect tape residue left from masking tape. It can also detect finger tracing. Here, I wrote "hi" on a whiteboard, and the similarity map shows a faint image of the letters. Unfortunately, the system does not perform well on felt surfaces, since the surface does not reflect as much light. It also does not work when the hand is covered by a sleeve, since it prevents any oils from the hand from staying on the surface. In conclusion, I present an evaluation of the laser speckle photography for surface tampering detection technique that uses the speckle reflections of a laser in a pair of before and after images to detect deformations on a surface for imaging surface tampering. Thank you for watching. Don't forget to like and subscribe.